Hey guys, this is the notes for module 2.2. Today we're going to be talking about reflections. We're going to be on page 73 in your textbook, and while you're turning to page 73 and getting out of some colors for highlighting and note-taking, I'm just going to talk about this example that's on the first page. So on page 73, you'll see that you have this quadrilateral ABCD, and it is going to be reflected over line L. And this is just a demonstration where they've used tracing paper. And so what they did was, in order to reflect it across line L, they folded the paper along line L. You can kind of see where L is now on the back side of this line. We're looking through the back of the paper. Tracing paper is, of course, really thin. And so when they do that, they're able to then mark the different corners for A and B and C and D on the back side of that paper. And then when they fold it back out the other way, they would have traced the figure on both sides, or they would be able to trace the figure on both sides. And it would, if they don't show it, it would look something like this. Okay, so maybe not entirely like that, but it would be in that general area. This figure would be C, or this dot would be C and also C prime. This one would be B and B prime, A and A prime, D and D prime. Some things that you might notice from this drawing include the fact that C didn't move. C didn't move because the line of reflection was going right through point C. You can see that up here. And so it's its own reflection because it sits on the line. Another thing that you might notice is, unlike translations where they simply slide the figure up or down, left or right, this one is a mirror image. And so if B was closer to the line on the original figure than A was, then in the new figure, the image, B is going to be closer to the, B prime is going to be closer to the line than A prime is. So it's a reflection. You're pretty familiar with the concept of reflections, I hope, so I won't elaborate too much on that. What we need to focus on is how to do them, how to reflect certain figures. And before we talk about exactly how to do that, the book is going to go into a little bit of review about perpendicular lines and perpendicular bisectors. We have talked about perpendicular bisectors already. It just reviews that perpendicular lines intersect at right angles. Line L is perpendicular to line M, and we know that because of this little box right here. A perpendicular bisector of a line segment also cuts it in half. So we have the perpendicular mark, and we know that A and whatever this point is, let's call it C, and CB are the same size because we have these congruent marks. Remember, matching marks for matching measures. So a reflection across a line, such as line L, would map a point, such as point P, onto its image, which is point P prime. If P is not on the line, then L is not going to be the perpendicular bisector. So here we have this idea that the original, the pre-image, and the changed version, the image, are connected by this line that might or might not be drawn for us. And the line of reflection, such as line L, the line of reflection is the perpendicular bisector of the line that connects the point and its image. Okay, so let's look at that example a little bit more. For this example, at the bottom of the screen, or at the bottom of the page, it says, draw the image of triangle ABC after a reflection across line L. Well, here's line L, here's ABC, and you're wondering, okay, well, how do we do this? So they have these steps to guide us. It says, draw a segment with an endpoint at vertex A. So here's A, here's a segment, so that the segment is perpendicular to line L. So how do we figure out lines are perpendicular? Well, we need to go back and look at their slopes. The slope of line L is, let's do it down here where I'm not going to have a lot of work. It goes down 1 and right 1. So it's -1 over 1, right? This one is down 1, this one is right 1, and we simplify it to just -1. So the perpendicular slope is going to be +1. We flip the fraction and we change the sign. Instead of negative, it's now positive, and just simplifies to 1. So we know that this slope needs to go from A out. And we know that it needs to start at A because it tells us up here, draw a segment with an endpoint at vertex A. So we're going to start at A and we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And it says label the other endpoint of the segment A prime. Well, how do you know when you're done? I'll tell you the way that I usually do it is I just count out how many repetitions of this slope I need to go from the point that I start with to the line of reflection. And then I duplicate that on the other side. Because remember, this has to be the midpoint. So whatever I do on one side of the line, I have to repeat on the other side of the line. So I did this slope 1, 2 times. So once I get to the line, I'm going to do it 2 more times. 1, 2 more times. Let's do points B and C on this graph and compare them with the next image. So again, I need to have a perpendicular line going from point B. So from point B, my perpendicular slope is still +1. So I'm going to go up 1 and over 1. I did that slope exactly 1 time. So I'm going to do it exactly 1 more time on the other side of the line. Up 1 over 1, that should be B prime. And again, with point C, I'm going from C using this perpendicular slope. So I'm going up 1 and over 1. So up 1 over 1, there's once, there's twice, and then I go up 1, so it's like a half. The other half is over 1. Okay, so I did 1, 2 and a half, and then there's my half, and then there's 1 and a half, and then there's 2 and a half. If you prefer to put dots like I did, you can just count and make sure you have the same number of dots on either side. I have 1, 2, 3 dots, 1, 2, 3 dots. That should work as well. So this point is going to be C prime. And your line would look like this. So what we have done is we have made line L the perpendicular bisector of each of the lines that connect the corresponding points. The corresponding points again are A and A prime, B and B prime, C and C prime. Once you have moved all of the points, you have actually moved your figure. So we're just going to connect A prime to B prime, B prime to C prime, and C prime back with A prime. And so these are your 2 shapes. I like to shade these in because the more you get on your figure, the more complicated it looks. And I feel like shading it in makes you see the 2 shapes a little bit better, right? So I don't want us to erase our work that shows us how we got there, but I also don't want the work to muddy up the picture. I need us to see what we've done. So we have taken ABC, triangle ABC, we have reflected it across line L into triangle A prime, B prime, C prime. And the way we did that was by making perpendicular bisectors, or making L a perpendicular bisector. And we just made all of these lines that were bisected by L. Let's compare ours with what it should look like up here. You can see that looks exactly the same as what we have done. The only thing we didn't do is we didn't go mark each of these congruent, but they are in fact congruent. We know that this segment is congruent to this one, and we know that this segment is congruent to this one. Now let's do our own example for B. Draw the image of triangle ABC after reflection across line L. So once again, we're going to figure out our slope of line L. If we need to make a line that's perpendicular to that, we need to know the slope of the original. So the slope of line L starts here, goes up here, right? So it goes up 1, that's our rise, and it goes over 2, and these are both positive numbers. So our slope of line L is 1/2. Our slope that would be perpendicular to that, we flip the fraction, we change the sign. If this is positive, that means this one has to be negative. And then we can simplify, and we need a slope of -2. One of the points on our image, our pre-image, will not move at all. I hope that you can recognize that that's going to be C. C has no distance from the line, so there's no distance to repeat on the other side. Because our perpendicular bisector, L, goes through this point is its own reflection. I don't have to copy that one again. So I'm going to start with that. Next, I'm just going to do angle B, or I'm sorry, corner B. So I'm going to count from this point, and I'm going to use this slope, -2. So I'm going to go down 2 and over 1, down 2 and over 1, okay? And I did that twice to get to my line of reflection. So I need to do it twice more on the other side because this has to be my midpoint. So I'm going to go down 2 over 1, down 2 over 1. I did that the same number of times on either side of the line. So I know that this segment is congruent to this segment. And so L is the perpendicular bisector of the line connecting B and B prime. Then we're going to do the same thing for A and A prime. So for A, I'm going to start here, go down 2 and over 1. So I only need to do that one time on this side of the line. So I need to do it one more time on the other side. Down 2 over 1. That's where A prime goes. And so we have made L the perpendicular bisector of this line connecting the point and its image. So now that we have all of our points placed, A prime and B prime and C prime, now we can connect them and officially finish our reflection of triangle ABC. So A prime needs to connect to B prime, needs to connect to C prime, and that needs to connect back to A. There we go. Let's shade that in a bit. Once again, just to kind of show a distinction between the work and the answer. The answer, or the finished product, is the two triangles. All of the lines and things in between, that's how we got there. So you can see this reflection of this triangle over onto this side. Okay, let's do number 6. Number 6 is a little bit different. This is our first one where we have our figure being cut by the line of reflection. The line of reflection goes through our figure. So let's look at the slope of this line. It says that it's line L up here, even though it's not really marked down here. So the slope of line L, okay, I can see that it crosses here and here. So I go up 1, 2, 3. That's my rise. And I go to the right 1. So that simplifies to 3. Our slope that is perpendicular to line L, we flip our fraction, change our sign. So if this one's positive, this one's negative. And that's the slope we're going to use to count out our segments. And our segments need to connect every point to where its image will go. So I'm going to start with A. And from A, I'm going to use the -1/3 slope. I'm going to go down 1 and over 1, 2, 3. Okay, well, if I do that one time, that takes me to my line of reflection. So I need to do that one more time on this side so that I have this point as a midpoint of that line. So I'm going to go down 1 and over 1, 2, 3. There's A prime. There's our line. So once again, we have made line L a perpendicular bisector of this line, which connects the original point and its image. Can't really see that this is prime right there, but it is. Now let's do point B. Point B, we're going to go again down 1 and over 3. Down 1 and right 1, 2, 3. Well, I did that one time. So this needs to be half of my line. The way I make sure that it's half is I do the same thing on this side that I did on the first side. So I'm going to go down 1 and right 3. And so now I have 2 equal halves of this line. So that means this is B, and this point over here is going to be B prime. Lastly, we have C. The process is still the same.